An arithmetic sequence is a sequence of numbers where each term after the first is found by adding or subtracting the previous term by a common difference. The formula for an arithmetic sequence is an equals a plus n minus 1 times d. The n in an stands for the ending term in the sequence. The a alone is the starting term. The n alone is the number of terms in the sequence. The d is the common difference. A geometric sequence is a sequence of numbers where each term after the first is found by multiplying the previous by a common difference. The formula for a geometric sequence is an equals a1 times r to the power of n minus 1. The n in an and the n alone is the number of terms. A1 is the starting term. R is the common difference. If I had a problem such as this one, I would use a sequence formula because I'm looking for a specific term and not for the sum of the sequence as a series formula may give me. But first I have to find the common difference to know which sequence formula I may have to use. To find the common difference, I need to see if a number has been added, subtracted, or multiplied from the first term to the next. As you can see, 4 goes into 8 plus 4 times. 8 goes into 12 plus 4 times. And 12 goes into 16 plus 4 times. The common difference is 4. Since the common difference is plus 4, you will need the arithmetic sequence to find out the sixth term. The arithmetic sequence is the ending term, which is an, because it's unknown, and the starting term, which is 4, plus the number of terms, which is 6, minus 1 times the common difference, which is 4. 6 minus 1 equals 5. 5 times 4 equals 20. 20 plus 4 is 24. The sixth term is 24. If there was a problem similar to this one, I would use a sequence formula because I'm looking for a specific term and not for the sum of the sequence. But I have to find the common difference first. 3 plus 9 equals 12. 12 plus 9 does not equal 48. So it's not going to be an arithmetic sequence because it's not adding or subtracting to the next term. 3 times 4 equals 12. 12 times 4 equals 48. The common difference is 4 because it's using a geometric sequence, which is multiplying 4 by each term. So we're going to use the geometric sequence formula to find the fourth term, which is the missing term is going to equal the starting term, which is 3, times the common difference, which is 4, to the power of number of terms, which is 4, minus 1. 3 times 4 to the power of 4 minus 1, which is 3. It's going to equal 3 times 64, which is 192. The fourth term equals 192. An arithmetic series is a sum of series with a constant ratio between terms that obtain adding or subtracting the previous term. The arithmetic series formula is Sn equals n times a1 plus an divided by 2. The s in Sn is the sum of terms. The n is the number of terms. A1 is the first term. An is the last term. A geometric series is a sum of series with a constant ratio between terms that obtain multiplying by the previous term. The geometric series formula is Sn equals A1 times 1 minus r to the power of n divided by 1 minus r. The S in Sn stands for the sum of terms. A1 stands for the first term. The R stands for the common ratio, and N stands for the number of terms. This problem is a series because we are finding the sum of the sequence. We also have to find the common ratio before we determine which formula we will use. The common ratio is similar to the common difference in a sequence formula, but not quite because only series have ratios. 4 plus 4 equals 8. 8 plus 4 equals 12. 12 plus 4 equals 16, and 16 plus 4 equals 20, and 20 plus 4 equals 24. The common ratio is adding 4. So it's an arithmetic series because it's using adding. So we're going to plug in the numbers. So the sum is going to equal the number of terms, which is 6, times the first term, which is 4, plus the last term, which is 24, divided by 2. Four plus 4 equals 28. Divided by 2 equals 14. 14 times 6 equals 84. The sum of this is 84. This problem is another series because we are finding the sum of the sequence. We first have to find the common ratio. 5 plus 5 equals 10. But 10 plus 5 does not equal 20, and 20 plus 5 does not equal 40. So it's not an arithmetic series because we're not adding or subtracting the terms. 5 times 2 equals 10. 10 times 2 equals 20. 20 times 2 equals 40. 40 times 2 equals 80. 80 times 2 equals 160. It's going to be a geometric series with a common ratio of 2. To find the sum, we're going to have the first term, which is 5, times 1 minus the common ratio, which is 2, to the power of 6 over 1 minus 2. Two to the power of 6 is 64. 1 minus 64 equals 63. And 1 minus 2 equals 1. And 5 times 63 over 1 equals 315. So the sum is 315. Summation notation is a formula used to give a concise expression for a sum of the values of a variable. The I underneath the summation sign is the starting point. The N on top of the summation sign is the stopping point. Let's say you're at a Bob's grocery store and you stack peaches into a square pyramid. Once done, you notice that the pattern of the top 3 layers has 1 peach, then 4 peaches, and then 9 peaches. This pattern continues for 15 layers. You're trying to see how many peaches there are to the 15th layer, so 15 is going to be your stopping point, which is going to be located at the top of your summation sign. The first layer has one peach, so that's going to be your starting point, which is going to be at the lower side of your summation sign. You have to have a consistent expression for each term till it gets to the 15th term. So you have to get 1 to equal 1, and 2 to equal 4, and 3 to equal 9 by using the same expression until you get to the 15th term. If you do I squared every time, then that is a consistency expression that works for this equation. As you can see, 1 squared equals 1, 2 squared equals 4, and 3 squared equals 9. 15 squared equals 225. If you keep on going down the number line, as 4 squared, and 5 squared, and so on, your answer would be 1,240 peaches in all 15 layers. Last week in our life lesson, we learned about retirement investment. We learned that if you start at an early age and inputting money into your savings account, your interest rate is adding to the money you have put in your account. Instead of waiting until you get older, then start saving your money. Your interest rate is still going to go towards your account, but it won't be as much as you would have if you started early. As you see, if I put $2,000 at the age of 19 and put it in for a small amount of time and then stop, the 10% rate is going to keep adding every year. And at the age 65, I would have $1 million, $63,159.56. Instead of I would have started at age 26 and then putting money every year. And with the interest rate at 10%, I would only have $883,185.11. It's better if you start early, because your interest rate will keep adding and you won't have little as money as if you would start late.